Welcome to the Cybersecurity channel. This is Sway. In this video, we're going to be doing a challenge 2 for GoogleCTF 2021 Beginner's Quest. So let's go ahead and look at the challenge. The challenge gives a quick description, and when we look at the bottom, it looks like we need to take a set of logic gates, and then there's no website to visit. It requires to download a file. So I went ahead and I already actually downloaded the file. So let's look at what was downloaded. It looks like it's challenge. It was a zip file that was really long. I renamed it to challenge02.zip, and then I unzipped it and got a logic locked a PNG file. So I'm gonna go ahead and I already have that PNG file open. So it looks like we have to actually do a so we're going to go look at the logic gates and figure out what the output is. So, alright, it's going to get bigger here. On the bottom it says the flag is going to be CTF inputs that need to be set, sorted, and then a bracket, if only inputs A, B, and C must be set, the flag will be CTF ABC. So it looks like we have to go through this logic circuitry to figure that out, what the flag is. So, let's go ahead and go to Google and let's find logic gates. And then let's go ahead and just go to the top. Actually, let's go to the picture here. Let's make it a different picture. Okay, it's a little bit better. Alright, so we got our logic gates here. So we're going to go ahead and use this to figure out what's going on here. Alright, so I'm going to start with the output and work backwards, so it makes it easier to determine kind of what we need. So the output gate, logic gate is AND. So if you take a look here, this is the AND right here. This one here. So it requires both inputs to be on in order for it to be turned on. So these two have to be on, so there has to be a voltage coming through to actually get it turned on, to actually get on here to be turned on. So let's start at the top. Let's go to the top part here. So we're going to go up here. Now we have another AND gate. So let me minimize this. Let's make this smaller here. Make this smaller here. Alright, so now we have another AND gate. Okay, so this is another AND gate. So again, this means that both inputs here have to be turned on in order for it to be turned on, for this to actually be turned on. So that means that this input and this input down here have to be on. So let's work down from the top now to get these on over here. So we have input A and B, and we have this logic gate here, and input B has to turn on another. Alright, so here we go. So this gate here is an OR gate. So, sorry, this gate here is actually a NOR gate. So for the NOR gate, both inputs have to be 0 in order for it to be turned on, which would turn this one on, which would turn this AND gate on. So this has to be a 0. And this has to be a 0. Okay, so this input here has to be a 0 in order for it to be turned on. So let's look at this gate here. So this is going to be on, so we know it's not going to be A, so we can cancel, so we can rule out A. So let's go ahead and rule out A. So let's go ahead and yeah, so let's go to rule A. Let's rule out A. So A is ruled out. So let's go to rule out A. Alright, so now let's go to the B input. So what is going on with the B input. So the B input is I actually don't have all the gates in this one. Let's choose a different one. Let's use this one here. Okay, so let's go ahead and so we already established that this was a NOR gate. So both A and B just go that one cool here. I like this one better. Yeah, I like this one better. Alright, so here we got logic gate. So here we got the NOR gate, which means that both A and B have to be false or zero voltage in order for the output to be turned on, which is this one here, to turn this on. Okay, so now we got the NOR gate, so A has to be 0, so we know that A is not going to be part of the flag. So now let's go to B. So the B input, this is going to go into a NOT gate. So if A is turned off, so we need A, so the input here has to be turned on in order for it to be 0, because if it's so 1 is true, 0 is false. If it's off, then it's true, then this turns it on, but we know that this right here has to be 0 voltage. So this has to be on, and if it's not 1, then it goes off, so this turns on this one over here. So we know that now we have the first letter, so we got, let's go ahead and just put this in here, in flag. Just put it in flag then, and then so we got the first one's B, insert B, so first one's B. Alright, so let's go down to this, back down here to this input. So again, this has to be turned on, this has to have voltage, this has to be a 1. So here we got another NOR gate, so these two inputs have to be zeros with 0 voltage to be, or below whatever voltage it gets turned on by, for this to be turned on. Okay, so we gotta work backwards. So we have to get these to be, this input here and this input to be 0. So let's go ahead and just go to this one. So this has to be a 0. So in order for it to be a 0, okay, in order for it to be 0, we go down to the OR gate. Alright, so the OR gate, and the only way that the OR gate is going to be 0 is if both of these inputs are 0. Okay, so D is already 0, so we know that's not going to be turned on because that's 0 voltage, so we won't get anything through there. So let's look at C. So C is a NOT gate. So in order for this to be 0, right? In order for this to be 0, this has to be turned on. Because if it's on, then this is off, and we get this OR to be 0, and then this is 0, so it works with this one here. So the C is actually on, so we can go ahead and rule that one out and make it a C here. Okay. Now let's go to the E and the F. Okay, so E and F. So E, this is another one. So this one, E has to be off so we want to get this to be 0 here to make this a 1 out here. So the F has to be, this F input has to have a voltage applied, so that's an F. Okay, so BCF. Okay, so now we got this top logic gate done. Okay, so let's go down to we got this half up here done. Now let's go to the bottom half here. So let's do this branch down here. So this is an AND gate, so we know that this has to be a 1 and this has to be a 1. Okay, so this right here has to be, and this is an AND gate here, right? So this is an AND gate here, and this is an AND gate here. So let's go from this AND gate here. So let's go off this one. Alright, so this G and H inputs, alright, so this G input is going into a NOR gate, right? So in order for the NOR gate to be 1, right, this one has to be, in order for this to be 1, I want this to be 1, this to be 1, so this will be, the G has to be off, right? So the G has to be off, so we know the G's off, and then the H, so this has to actually not have voltage on it. So if this right here, this H taps into this line here, which gives it voltage, so this one actually has to be, in order for this to get 1, this H line also has to have 0 voltage applied on it, because we go to the NOR, 0, 0 gives us a 1, and we want this to be a 1, so H is 0. Alright, so now we know that H is going to be 0. So we go to H right here to be 0. Okay, so we want this to be a 1 right here. So this has to be a 1, and this is 0. So what type of gate is this? So this gate right here is an XOR gate. So an XOR gate, right, it has to be exclusively OR, so you can't have both inputs be 1. It has to be one or the other. So this is a 0. So this one has to be a 1 in order for this to turn on right here. So the I has to be a 1. Okay, so if the I is a 1 and the H is a 0, this turns into a 1 because this is true when 1's 0, the other one's 1, then it's true, so the voltage is applied. So I is the next one, so I is on. Okay, so now that we have I on, this is on, so I is 1. And then we go to this gate. So this is an AND gate. So this means that both of these inputs have to be turned on. The J input and the I input coming in here to be turned on has to have the voltage applied. So this is a J. So the J, both of these have to be turned on. So there's a J. So the J has to be on. So BCFIJ. So let's go ahead and try that flag and see what happens. BCFIJ. 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 Submit. Perfect, the task was completed. Awesome. Thank you for watching this video and you want to learn a little bit about logic gates. And if you liked the video, please hit the like button or subscribe to my channel. Thank you.